The universe is vast beyond imagination. Measuring over 93 billion light-years in diameter is the observable universe, the part of the universe that can be seen from Earth. The universe is full of mysteries, including its actual size, because we are limited to observing it through our telescopes, satellites, and spacecraft, and we can only see so far. The universe also holds a mystery that has fascinated people past and present, the question of whether life exists beyond Earth. And not just life, but intelligent civilizations like our own. But just like our observations of the universe, our tools are limited, and so far, no one has been able to answer the question, are we alone? If you look up at an unpolluted night sky, you can see thousands of stars, but they represent just a tiny fraction of stars in the Milky Way Galaxy. The true number is likely at least 100 billion, and the Milky Way is one of many hundreds of billions of galaxies in the observable universe. Astronomers have estimated the number of stars in the observable universe to be 10 to the 22nd power, but there are likely many more stars. In our galaxy, astronomers have found planets orbiting other stars, called exoplanets, to be quite common, with estimates of 1 planet per star in the Milky Way. With so many planets, it seems likely that there would be extraterrestrial civilizations in the galaxy. The universe is approximately 13.8 billion years old, but our planet is just 4.5 billion years old, and the Homo sapiens species has only evolved in the past 200,000 years, meaning there could be other civilizations far older and more advanced than our own. But despite 7 decades of looking, we have not been able to find any evidence of intelligent civilizations elsewhere in the galaxy. Astronomers have developed many theories as to why we've been unable to find other civilizations, and they broadly fall into 2 buckets. Earth and our civilization is the exception, not the rule in the universe, and secondly, there is life out there, but for various reasons we are unable to see it. One of the most famous aspects of the search for extraterrestrial intelligence, or SETI, is the Drake equation, a formula that could be used to quantify the number of detectable extraterrestrial civilizations in the Milky Way Galaxy. The main problem with the formula, however, is that of the 7 inputs, 4 are completely unknown, while the remaining 3 are just estimates. The first input, the rate of star formation in the Milky Way, has the firmest scientific footing, with current estimates suggesting about 1 or 2 stars are created in our galaxy each year. The second input is the fraction of stars in the Milky Way with orbiting planets. Due to the discovery of over 5,000 exoplanets in recent years, including some stars having multiple planets just like our solar system, it is believed that most stars in the galaxy have 1 or more planets, meaning there could be over 100 billion planets in the Milky Way alone. The third part of the Drake equation, the average number of planets that can support life, isn't known with any certainty, but astronomers have found exoplanets that are at a sufficient distance from their host star to allow for liquid water to exist on the surface, a region called the Goldilocks zone. Much of our knowledge about exoplanets is due to the Kepler Space Telescope, whose mission was to find Earth-like planets in the galaxy. Many of the exoplanets found so far are either Jupiter-sized, orbiting close to its host star, or both, because those planets are relatively easy to find. The number of planets that qualify as Earth-like is debated by astronomers, with some putting the number in the galaxy in the billions, while others say there is exactly 1, Earth. The rare Earth hypothesis, first proposed by Donald Brownlee and Peter Ward, proposes that our planet holds the right combination of attributes that make life possible, and that this combination is unlikely to exist elsewhere in the universe. First, Earth has a relatively stable orbit around the Sun. Its orbit is elliptical, but is quite close to a perfect circle. Our low eccentricity orbit contributes to a stable climate that life of all kinds can adapt to. In contrast, the orbit of exoplanet HD 20782b is highly eccentric, meaning during its orbit it will get very close to and very far from its host star. With such extreme variations, it is not expected that any life would be able to exist in that harsh of an environment. Earth also has an axial tilt mild enough to allow for seasons with acceptable temperature variations. Our 23.4 degree tilt is much different from Uranus's 98 degree tilt. If Earth was tilted 98 degrees on its axis, much of the northern and southern hemispheres would get 0 sunlight during the winter months, followed by 24 hours of daylight in the summer. Another advantage Earth has going for it is our moon. While it is not uncommon for planets to have natural satellites, Jupiter has at least 80, the size of our moon relative to Earth is notable. The moon is the fifth largest natural satellite in the solar system, but the largest when compared to the size of its host planet. The moon's size relative to Earth causes ocean tides and helps stabilize the Earth's wobble around its axis, a phenomenon known as precession. Another attribute that likely contributed to the development of life on Earth is the presence of large planets like Jupiter in the outer solar system. Jupiter's large mass allows it to capture comets and keep them from entering the inner solar system where they could collide with Earth. Our planet also has a molten core that creates a magnetic field, protecting us from the sun's most damaging radiation. Earth's mass is also sufficient to allow for an atmosphere and liquid water to exist on the surface. And finally, another interesting feature of the rare Earth hypothesis is Earth's plate tectonics. Earth is the only celestial body known to have plate tectonics, which helps regulate the planet's climate and stores carbon, preventing runaway greenhouse gases. In contrast to the rare Earth hypothesis is the Mediocrity Principle, which holds that Earth and humans do not occupy a special place in the universe. It says Earth is just a typical planet orbiting an average star in an ordinary galaxy, and that if life can exist on Earth, there are plenty of other places life can exist. A key part of the Mediocrity Principle is the sheer numbers of the universe. With the hundreds of billions of stars and likely planets in just our galaxy, along with the seemingly infinite other galaxies and stars, it stands to reason that the right mix of conditions similar to Earth will occur elsewhere, allowing life to develop. And since we only know of life on Earth, humans only have ourselves as a frame of reference. We look for exoplanets with conditions similar to Earth, but the universe could have civilizations in which life has totally different properties. The arguments of the Mediocrity Principle face a challenge that was articulated by astronomer Enrico Fermi. If the sheer size of the universe and the billions of other planets likely to exist in the galaxy indicate a high probability of extraterrestrial life, why haven't we found any? Many have suggested possible solutions to the so-called Fermi Paradox, but until definitive evidence of an extraterrestrial civilization is found, no one can say they exist with any certainty. Conversely, even if humans are the only intelligent life to have ever existed, we have no way of establishing this as fact because there is so much we do not know about the universe. Assuming that there are planets in the galaxy that have the right conditions to host life, the fourth input of the Drake equation is the fraction of those planets that actually do develop life. A key part of the debate about extraterrestrial life is the Great Filter hypothesis, which says life in the universe is rare because at some point in its development, life hits a barrier that it cannot overcome and goes extinct. Where exactly this barrier would be in the development of life and intelligent civilizations is debated, but if true, the Great Filter hypothesis could have dire implications for humanity. It's possible humanity has already overcome the filter that life elsewhere cannot triumph over. Maybe life developing at all is extremely rare. Such circumstances would be good news for us because we have crossed that barrier, but it's also possible that the filter is in our future. Whether it be civilizational war, significant changes to a planet's climate, or something beyond our control like a nearby gamma ray burst, we might not see any intelligent life in the galaxy because it has all gone extinct. This dynamic would obviously be devastating for humanity because our filter would be ahead of us, not behind us. Much of our exploration of other celestial bodies to date has been centered on Mars because it has some similarities to Earth. Mars is a rocky planet, has a similar length of day, and likely had liquid water on its surface long ago. If life does or has existed elsewhere, Mars could be one of those places. In the opinion of one academic, though, we should hope to never find any trace of life on Mars. Nick Bostrom has said that the discovery of any extinct life on Mars would be bad news because the implication would be that life is the norm, not the exception in the universe. If simple life existed on Mars, it likely exists elsewhere, ruling out many of the filters that would be behind humanity. Combined with the lack of evidence of intelligent civilizations, it would suggest that a filter is ahead of us. Another perfectly plausible explanation for the Fermi Paradox is that extraterrestrial life does exist in the galaxy, but we are unable to detect it because of our ignorance. It's possible that we just have not developed the necessary tools to detect extraterrestrial life, or we misinterpret the creations of other civilizations to be natural phenomena. The search for extraterrestrial life primarily involves scanning radio waves for signs of communication from other civilizations, but what if other civilizations don't use radio waves? Humans use radio waves because they are useful for transmitting information over long distances, but there may be better ways of communicating that we have not yet developed the necessary technology to utilize. Along this line of thinking, we may not be able to perceive the presence of other civilizations, but they are aware of our existence and choose not to make themselves known to humans. Earth may be like a zoo in which other civilizations observe us, but have strict no-contact rules, making it impossible for us to detect their presence. Being unaware of extraterrestrial civilizations wouldn't be a problem if they don't have negative intentions for Earth, but if they are hostile, our ignorance is a major liability. A disturbing possibility is the presence of a far more advanced civilization that has the capacity to annihilate other worlds. Maybe it leaves other civilizations alone unless they develop to the point where they can challenge the apex civilization's hegemony and are destroyed in a preemptive attack. Another scenario, often the subject of sci-fi movies, is extraterrestrial civilizations that colonize and plunder other worlds for resources and cause the extinction of the local population in the process. Either option clearly would be bad news for humans, and it would be made worse by the fact that we have not exactly been hiding our presence from the galaxy. Our radio signals have been traveling into space for over a century. There are plenty of theories about extraterrestrial life in the galaxy, but they are all speculative because there is so much we do not know. Even if intelligent life does exist, if they do not release signs of their existence into the universe, it would be impossible for us to find them. The remaining parts of the Drake equation are the fraction of planets that develop intelligent life, the fraction of intelligent civilizations that emit detectable signals of their existence, and the length of time those civilizations emit those signals into space. The Drake equation does not deal with the number of extraterrestrial civilizations, but instead the number whose presence can be detected by humans. Humans do not possess the technology to spot life on faraway planets orbiting other stars, so other civilizations have to make themselves known if we are to have any chance of finding them. Without any evidence of extraterrestrial civilization so far, some have advocated a more active search that involves intentionally broadcasting our presence to the stars to increase our chances of getting a response. The search for intelligent life to date involves listening and observing the universe. It is possible making our presence known could increase our chances of finding life, but it carries significant risks too. Submarines have active and passive sonar to help detect nearby submarines and ships. Using passive sonar, the submarine listens for sound waves emitted by nearby submarines and tries to acquire their exact position. Passive sonar is like our current methods for searching for extraterrestrial life. When a submarine uses active sonar, it emits sound waves, and if there is a nearby submarine, the sound waves will bounce off its hull. Working similar to radar, a submarine using active sonar will be able to find other submarines or ships. However, a submarine using active sonar is broadcasting its position to nearby vessels that can then identify where the submarine is. By emitting signals of our existence into the universe, we would be telling anyone listening exactly where we are. And if another civilization was out there and had bad intentions, broadcasting our presence and location would be precisely the wrong thing to do, something many astronomers have warned about. In the grand scale of the universe, our search for extraterrestrial life has been limited in both time and scope. We have only been looking for several decades, a mere rounding error in the billions of years the universe has existed. We have only been looking at nearby star systems. The wider galaxy remains a mystery, to say nothing of the billions of other galaxies. The question of whether we are alone or not can be answered if we find extraterrestrial life, but until we do, it will not have a definitive answer because of how much we still have to explore.